Okay guys, I'm doing number 33 from the textbook. It says vector B has x, y, and z components of 4.00, 6.00, and 3.00 units respectively. Calculate the magnitude of B and the angles B makes with the coordinate axes. To find the magnitude of vector B was fairly simple. All we had to do was take the square root of the squares of each respective component that the vector had. Doing that gave me 7.81 for the magnitude of vector B. To find the angle was slightly more complicated, and I used the definition of a dot product, which is defined as A dot B equals the magnitude of A times the magnitude of B times the cosine of the angle between them. So to find the angle between vector B and the x-axis, I assumed vector A to be along the x-axis and have a magnitude of 1.00. So the dot product between these two vectors divided by each of their magnitudes would give us the cosine of the angle between them, which is what I got by rearranging the equation on top. Next, you basically just find the dot product between this vector B and vector A, which gives you the cosine of theta x, which is the angle between the x-axis and the vector, to be 59.19 degrees. For the y-axis, I used a similar procedure, except instead of choosing the vector along the x-axis, I chose it to be along the y-axis. So its components were 0 I hat, 1 j hat, and 0 k hat. And then b dot c would be equal to the magnitude of b times the magnitude of c times the cosine of the angle between them. Rearranging this equation for cosine of theta and solving for theta, I got that theta equals 39.81 degrees. Similarly, for the z-axis, I assumed my vector to be along the z-axis, so along here, and said its magnitude was 1, so its components were 0 I hat, 0 j hat, and 1 k hat. And then, using a similar process to what I did before, I found that the cosine of the angle was 67.41 degrees.